Hi guys, so today what we're going to do is we're going to look at how to evaluate some of these trig functions we've been looking at using our calculator. So we're going to look at two different ways to look at it. So go ahead and get out your calculator if you don't have it already. And the first thing we're going to look at is evaluating where it says f of 8. So if you remember back from Algebra 1, Algebra 2, f of 8 means what do you get when you plug in x for 8. So I'm going to plug in x for 8. Okay, so I can do this a couple different ways. One way is I could just do this on the main screen of my calculator, but since we're going to be using this for some other things, I went ahead and already plugged this equation into y equals. So go ahead, take out your calculators, and plug this into y equals, and plug this into your y1. Now you notice I did mine a little bit differently, and that's okay. To get that fraction that looks like the way it is with a pi over 9, if you want to do that in the new operating system, you do alpha and then f1. And then it's that n over d, and that's how you can get your fraction to look like that pi over 9. But if you don't have that, that's okay. You don't need it. Okay. So once you have your thing typed in, one thing you really need to pay attention to, if you notice, is that everything here, the pi over 9 and the x minus 6, that whole thing makes up what's called the argument of cosine. Okay, it's what you're actually taking the cosine of. What you cannot do is you cannot close your parentheses after the pi over 9. That's going to give you a really bad looking graph. You have to make sure that the pi over 9 and the x minus 6 both come after the cosine. Okay, the other thing to pay attention to is our mode. Since we have a pi over 9, okay, our mode here should be in radians. So double check your mode and make sure that you're in radians. All right, so now let's go ahead and get a graph. And this is just a standard window right now. So we'll see if this is enough for us to see our graph. It looks like it is. So I want to know when x equals 8, what does y equal? And again, there's two ways I can do this. One, since 8's not a very big number, I can just go to my table. So second table. And I'm going to scroll to when x is equal to 8. And my calculator scrolls a little slowly, but we'll get there pretty soon. All right, and there we go. And that gives us our value when x is equal to 8. Okay, it's at 4.2981. The other option here, what we can do is I can do second trace. And then where it says value, I can press enter. And then it says x equals. And then I type in what I want x to equal. I want x to equal 8. And when x equals 8, it gives me that same value, that 4.298. So when x equals 8, y equals 4.298. All right, the next thing I want to do is to find the first three positive values where f of x is equal to 1.3. Okay, so again, this time the x, okay, we don't know. What we know is that y is equal to 1.3. Okay, and again, we're going to use the calculator to do this because it's going to be a little bit simpler. So what we're going to do is we're going to go back to our y equals. And I want to know when y is 1.3. So I'm going to go down, I'm going to make my y2 1.3. And then I can graph this, and you can see some of these intersection points. Everywhere those graphs intersect, that's one of my answers. Okay, so a couple things here. I'm going to need to change my window first of all, because it wants the first three positive values. So the first value I see here where it intersects, that x value there is going to be negative, so we don't want that one. Okay, so I do have one over here, but that's all I can see. So I'm going to need to change my window. On my window, I'm going to need to change my x values, because my y's are pretty good. So I'm going to make my x min 0, because I only care about positives. And then let's make our x max a little bit bigger. Let's go to 20 and see if that's enough. All right, so now it's going to graph, and we're going to look for these intersections. So there's 1, there's 2, and there's 3. So I do have 3 intersections. Now I want to find what those are exactly. So I'm not going to trace, because that's not a very exact answer. To get this exactly, like you did when you solve systems of equations, you do second trace, and then we do intersect, number 5. Now, you know that you're supposed to press enter, enter, enter to find that intersection value, but since we have more than one, we need to do another step first. That little blinking cursor, whichever intersection it's closest to, is the answer it's going to give you when you press your enter, enter, enter. So I want to be closest. I don't have to be right on it, but my closest intersection needs to be that first one. So I moved over to where that one's closer, and now I'll do enter, enter, enter. So my first intersection is 0.825. And these won't stay on here because I'm using the calculator, but you can make sure you write them now. So 0.825 is the first one. And then I'm going to move my calculator over to get the next one. So same thing, second trace, intersect. I'm going to scroll over. And again, as soon as it's closest to that next intersection, I can press enter, enter, enter. And that gets me the next one, which is 11.175, if we go ahead and round that. So that's 11.175. And then we can get the third intersection. So we're going to do it the same way. I'm actually going to show you guys a shortcut here. You don't have to use this, but if you get tired of scrolling, especially on this calculator, it's kind of slow. What I'm going to do is I'm going to go ahead and press enter, and then I'm going to press enter again. Now it says guess. And what I'm going to do is I'm going to type a guess as to where this intersection is. Well, I know my window ends at 20. So it looks like it's kind of close to 19. So I'm going to go ahead and just type in 19 as my guess. And it's going to give me an intersection that's close to 19, which is this value right here, which is 18.825. And that's my third value. Now, one thing you may notice, look at the difference between the first value that we found and the last value that we found. They're exactly 18 away from each other. Well, using what we know about these sinusoidal functions, look back at your original equation. My b value is pi over 9, which means that the period is 2 pi times 9 over pi, which is 18. Okay, so again, your first and your last value, the distance between them, it's exactly the amount of the period. And if you look at your graph, it looks like it's completed one full cycle at that point. So that's something that you'll see happen. All right, we're going to try one more. So let's go to y equals. And we're going to type in our new one. Okay, so 4 plus 3 sine pi over 6. And again, let me go ahead and delete this so you can see how I enter that value in. This does not want to go away. Okay, so we'll type this in from the start. So 4 plus 3 sine, and then again, you don't have to use this next little feature. I'm just going to do it so it looks a little clearer. Alpha F1, and then n over d, that's numerator over denominator. And then I've got pi over 6. And I am not going to close my parentheses. That's the important thing. I need to open a new set of parentheses. And then I type in x minus 2. And I can close both of these. Okay, so now, I need to evaluate f of 37. That means when x equals 37. So I can go to my table and scroll down to 37. Or I can do second trace value. But again, remember, if you do second trace value, there is a little trick with that. Now, if I do it right now, I'm going to get an error, and I'll show you why here in a second. Okay, so it's going to go ahead and graph my function. I have a pretty good window here, so that's encouraging. Okay, but watch what happens when I do my second trace value, and that's the line from the previous question. We're going to delete that here in a second. If I type in 37, I get an error. The reason for that is because my window is not big enough for that value. So what I need to do is I need to make my window at least as big as that x value if I'm using that second trace value. So I'm going to go ahead and make my x max 40. Whoops, not my scale, sorry. And now I can do second trace value, and I can use any number as big as 40. Okay, so second trace value, your window has to be at least that big or it's not going to work. So just keep that in mind if you get an error. Again, if you want, you can always just go to your table and scroll, but sometimes this can just be a little bit faster if it's a really large number. All right, so second trace value, I don't know, when x equals 37, it tells me that y is equal to 2.5. And the last part, I want to find the first three positive values where f of x equals 6. That means when y equals 6. So y equals 6. And we'll go ahead and do our intersections. And we're definitely going to see at least 3 here. We're going to see a lot more than 3, but we only need the first 3 values. All right, so there's 1, 2, 3, 4, 5, 6, 7 intersections actually, but we only need the first 3. If you want to make your window smaller, you can. In this case, I'm not going to. I'm just going to scroll. So second trace intersect. And then, again, I'm going to take a little shortcut here, and I'm going to go ahead and put a guess in, okay? And I'm going to get the one that's closest to 2. It's not at 2, but it's kind of closer to it. And that gives me that first one. It's at 3.394. Okay, now I want my next one, so let's do second trace intersect. Enter, enter, and again, I'm going to type a guess in. Let's say 8. And let's get the intersection closest to 8. Okay, 6.606. And then the last one, this one I'll go ahead and trace on. So I'm going to scroll closest to that third intersection. So I'm closest to it, enter, enter, enter. And it gives me my last intersection, which is 15.393. And again, that's 12 away from our first point because 12 is the period here. All right, so that's how we're going to use our calculator to help evaluate some of these functions. So just remember, we're going to use y equals mostly, and the biggest thing to make sure of is, whenever you're in y equals, make sure your mode is correct, and make sure you do not close the parentheses after the pi over 6 or pi over 9. You have to include all of that second part as part of the argument.